Hi everybody, this is me Vinu Venkatesh again on behalf of Sai Education for Competitive Examinations. So let us continue our lecture on surds and indices. We discussed last time, we discussed till number 9. Let us start with number 10 today. So what is square root of 5 square into 3? So here it's very simple. Now square root of 5 square into 3. Now 5 square, this can be written as square root of 5 square into square root of 3. We know that square root of 5 square is nothing but 5. Why? Because square root of 5 can be written as 5 raised to 1 by 2, brackets raised to 2. The 2 and 2 get cancelled and therefore it is 5 into square root of 3. So the answer is 5 root 3. You need not do the step, but you know that square root of 5 square into 3. Now you know that 5 square is 25. Obviously square root of 25 is 5. So this is how you solve it. Okay. Then number 11 is similar to what we did. Root 5 plus square root 3 into square root of 5 minus square root of 3. What does this look like? It looks like a plus b into a minus b, right? And it can be written like that. And what is the formula for a plus b into a minus b? It is a square minus b square. So this would be nothing but root 5 square minus root 3 square. What would that be? Simply 5 minus 3, which is 2. And that is the answer. Alright. Now, number 12. Cube root of 5 raised to 3. Now, we have done this, but let me do it again. Now, cube root of 5 can be written as 5 raised to 1 by 3. Brackets raised to 3. Now, 3 and 3 will get cancelled. Therefore, the answer is 5. Remember that nth root of any number can be written as that number raised to 1 by n. Okay, so for example, 10th root of say 5 can be written as 5 raised to 1 by 10. So that's why I got cube root of 5 equals 5 raised to 1 by 3. The whole thing raised to 3, which leads us to cancel 3 and 3. By the way, when you write cube root, that 3 should be very small. Otherwise, it will be misunderstood. Okay, I'm just writing it very small. Okay, so that's where we are. And they have given you some common roots like root of 2. Square root of 2 is 1.414. Square root of 3 is 1.732. Square root of 4 obviously is 2, that you know, and so on. Please try and memorize these square roots. Just get an idea, okay? At least know them so that if they're suddenly asking in a question, you know what they are referring to. No need to memorize, but at least know square root of 2, 3 and so on. No need to know everything, but please have an idea. Okay, number 13. Square root of 27 plus square root of 125. First question, can you add them? Can I say that this is equal to square root of 27 plus 125, which is 152? No, I can't. Why? Because the terms in the square root, they are not the same. Remember, we did some questions previously where we said that we can add and subtract the terms only when the terms in the square root are the same. Here they are not the same, so we cannot directly add them. We have to simplify them. Okay, let's see how. So here we go. Now square root of 27 can be written as 3 into 3 into 3. What is 3 into 3? 9. 9 into 3 is 27. So 27 can be written like that. 125 can be written as 5 into 5 into 5. So now this is a pair. This is a perfect square. 3 into 3, 9. So we can take that. So we can take this out, right? We can take this out, right? So it will be 3 root 3 plus 5 root 5. Why 5 outside? Because out of the 3 5s, there are 2 5s here which are perfect square, right? So the square root of these two is 5. So 5 root 5. So the answer is 3 root 3 plus 5 root 5. Can I say that this is equal to 8 root of 8? No, I cannot add this any further because the terms or the numbers under the square root, they are not the same. If this was root 3, then I can say the answer is 8 root 3. or if this was root 5, I can say the answer was 8 root 5. But since the numbers in the square root are not the same, I cannot add it any further. Okay. Right. Let's move to number 14. Square root of 20 plus x is equal to square root of 180. Then what is x? This question mark is x. So let's work it out. So let the question mark be x. Therefore, square root of 20 plus x is equal to square root of 180. Therefore, x is equal to square root of 180 minus square root of 20. Can I directly subtract them? No. Why? Because the numbers in the square roots are not the same. Okay, same explanation that we gave here. But let us factorize these numbers so that we can simplify it the way we did it. So 180 can be written as what? 2 into 9 into 10, right? 2 into 9 is 18, 18 into 10 is 180, okay? So 2 into 9, which can be further factorized as 3 into 3, into 10, which can be factorized as 2 into 5. So 3 into 3 is a perfect square, we can take it out. 2 into 2 is also a perfect square, you can take it out. So if I take 3 into 2, it becomes 6 root 5 minus square root of 20 can be factorized as, what is 20? 4 into 5. 4 can be written as 2 into 2 into 5. So this is another perfect square. So I can take 2 out. So then the first term becomes 6 root 5 minus 2 root 5. Now, can I directly subtract it and say this is 4 root 5? I can. Why? Because the number in the square root sign is the same. It's root 5. Number in the square root sign is the same. It's root 5. So I can subtract it directly. But in the previous question, I could not do that because the number in the square root sign were different. Right? So 4 square root of 5 can be written as, if I take 4 inside this, then what would happen? It would be actually 4 into 4 into 5. Why am I putting 4 into 4? Because remember we said now 4 into 4 is a perfect square. So therefore I can remove it out of the square root sign and this can be written as nothing but this. So from here, if I have to get here, this means that 4 is a square root of some perfect square. What is that perfect square? It is nothing but 16, which can be written as 4 into 4, right? So if I want to write everything within the square root sign, I have to put it back into the square root as a perfect square. 4 is the square root of a perfect square, which is 16. So 4 becomes 16 inside the square root symbol. I can write 16 as 4 into 4, right? Into 5, which is already there in the square root symbol. So this becomes square root of 80, which is what is given here. Okay, you can even write it as 4 square root of 5. That is also correct. You'll have to see what answer choices they have given and accordingly tick it. Sometimes the answer choice may be given as root of 80, but your answer may be 4 root 5. So you should know that we can so since if the answer choice is square root of 80 and your answer is 4 square root 5, you should try putting this 4 inside the square root symbol, and you can do that only if you can do that, and when you do that, this 4 inside the square root symbol becomes a perfect square. What is a perfect square? 16, and 4 is the square root of that. So any number that is a perfect square within the square root symbol can be taken out and written as the square root. So 4 is the square root of 16. So if I have to put this within the square root symbol, I have to write the perfect square of 4, which is 16. Okay, so you have to be careful what is given in the answer choice. You should see if you can convert your answer in such a way that it matches the answer choice. Okay. Number 15. What is square root of 675 divided by square root of 243 equal to? All right. Put everything under a big square root sign. 675 can be written as 25 into 27. First try and simplify the numbers that are given. Okay, divided by, what is 243? Let us see if we can divide it by 3. Yes, it is 81. 3 into 81. Let us factorize this further so that we can simplify the question. So 25 can be written as 5 into 5. 27 can be written as 3 into 3 into 3. Okay. Then in the denominator you have 3 and then you have 81. 81 is what? 9 into 9, right? So 3 into 3, which is 9. Again 3 into 3, which is another 9. So we're factorizing it further. Now these 3's and these 3's get cancelled. What are you left with? 5 into 5 divided by 3 into 3. Square root of 5 into 5 divided by 3 into 3 is nothing but 5 divided by 3, right? Square root of 5 into 5 is 25. What is square root of 25 divided by square root of 9, which is nothing but 5 by 3. And that is the answer. Okay. Now number 16 is similar to the previous questions that we have done. So please do it yourself. This is actually number 17, not 30. Let's do that. Root 45 into x. X is not within the square root sign. Be very careful when you read the question. Is equal to square root of 320, the whole thing squared. Okay. Let's try how to solve this. Let's see how to solve this. Okay. So if I remove the brackets and take the square of each term, we have to do that because it is square here. So that's how we solve it. This becomes 45. Square root of 45 whole square is nothing but 45 into x square, correct, is equal to 320. So x square is equal to 320 divided by 45, which if you simplify, you'll get 64 divided by 9. Therefore, x is equal to root of 64 by 9, which is nothing but 8 divided by 3. Because square root of 64 is what? 8. You should know it. Divided by square root of 9 is 3. So x is 8 divided by 3. Correct. Okay. Now number 18 is similar to, I think, which question was this? Number 18 is similar to number 8. But only difference is they have given the values of root 3 and root 2. So first do it the way we did number 8 and then put the figures in and then simplify it. Number 19, we have done similar question. You can do it yourself. We cannot directly add or subtract because the numbers within the square roots are not the same. So you first have to factorize it, simplify it, and then see whether you can add or subtract. Number 20 is similar to what we have done. So you can try it out. We will start indices in the next section, in the next lecture. So until then, please keep practicing, know all the formula, the rules, because without that you can't go any further. So see you next time. Take care and all the best.